Okay, then I'll begin. Okay, so you've just heard Joseph's piece talking about evaluating the fairness of degree classification. The way that he did it is looking at labour markets. How much is it having a first changes what goes on in the labour market? We decided to do it differently by looking at clustering. We asked the question, of the people who get a first, how similar are they to each other? And then how much does that change year on year? So the type of people who get a first in 2018, are they similar to the type of people who get a first in 2015? That's the basic question we asked. Okay, is the LSE examination system fair? The problem here is how the hell do you define fair, right? There's 1,000 different ways you can cut this. For example, we decided to go for internal consistency. So our question isn't, is it fair, but is it equally unfair every year? Or is it as bad no matter which year you sit it in? Because I think we would all agree it's a bad thing if sitting your exam in 2018 means that it's very, very easy to get a first, but sitting your exam in 2014 is very hard just because the examiner is different. So that was the question we tried to address. We were also quite shocked to find a lack of literature on this, especially because there's so much data available. This is the type of question that statisticians really liked, so we were really surprised to find that there wasn't more on it. How does the grading system work? This is the context you need for this. Okay, so you have we look at the master's grading system. In your master's, you have 4 modules. If 3 of them are above 70, then you get a distinction, and it doesn't really matter what the other one is. That's how the grading system works. Now, what we're going to do here, I'm just going to show 2 examples of how this looks a bit unfair. 2 examples of how this is a bit weird and just makes you raise your eyebrows. If you take the first line in this table, you see, if you take the first line and the second last line, in the first line, you see someone whose total score is 290, and they only get a merit, and you see someone else's total score is around 270. So there's a 20-mark difference there, which is massive. But what's interesting about this is the person with the lower mark, it's just interesting because although the marks change, you just get different scores, right? The person with the lower mark is the person that also gets the lower class, is the person with the lower mark overall gets the higher classification. And this is just weird, right? This person gets 70, 70, 70, 62. They just scrape it in, and then they get a high mark, but someone who's doing a lot better overall doesn't get equally rewarded. So the kind of point of this is just to raise your eyebrows, but there is kind of something here. Some of these weird cases are getting fudged through. Okay. We're going to talk about the analysis. What is K Nearest Neighbours? What did we try and do? So we read the literature. We found a lot of different ways of doing this. Because there's not very much on examinations and what makes examinations fair, we ended up looking at the literature for other things. So for example, you can look at grade inflation, and we just read lots of other papers and lots of different ways of deciding this. We ended up choosing K Nearest Neighbours in the end after like quite an extensive literature review. But what I want to kind of point out now is the constraints that we the constraints we faced there. So the first thing is it was quite difficult for us to get our hands on the data. So while we were doing the literature review, we chatted with our mentor, who at the same time got data. So we managed to get everything for the master's classification. But what our plan was to do more degree titles and stuff. But because when COVID happened, the LSE examinations team just had bigger fish to fry. So we did 6 years under LSE examinations, but we wanted to do more but didn't because COVID. Also, the question I just saw come in was, have you looked at the gap from Bain? No, we haven't, but the reason for that is because LSE examinations, it's anonymous, right? So you could look at this and it'd be really interesting to do, but our data didn't have that because the people who sit the exams are anonymized before they go in. Also, things like names are taken off, so it's meant to be kind of blind marking. Okay, so that's the context. And then going into this, Miles, would you like to talk about?
Cheers, Matthew. I hope everyone can hear me. I understand that I'm a bit pressed for time, so I'll try and do this as well as I can. I go much more into detail in the official write-up, but I'll just try and talk through actually what we did with the K Nearest Neighbours. So what we did was we took the raw marks and the actual degree classifications which actually were given in 2012, 13 and 2018 for Masters Economics. And the gist of the research was basically to see if the same type of student given just the 4 raw marks got the same classification year on year. And how K Nearest Neighbours does that is it takes 1 year's exam results, plots it in 4-dimensional space, and that's the training data, and it knows which degree they were given. Then, so for example, that's 2012. Then it takes the 2013 marks and then looks at each individual student, plotting them in four-dimensional space, not knowing its classification, and see who's it's closest to. So for example, if a 2013 student was very, very close to lots of people in 2012 who'd been given merits, then that person would be given a merit by K Nearest Neighbours. So basically it's all done given geometric proximity. Matthew, would you skip on to the next slide? And so the output of that looks like this. So this is just one example, 2013 cohort, what they were actually given against what they should have been given, or the machine thought they were going to be given 2012 marks. So for example, here we see that 7 of the people who were given distinctions in 2013, actually the machine thought that 7 of them should be given merits instead of that. So how do we know whether that's good or not, how consistent that is? Well, we compared it to the normal classification system, which is just, you get 70%, averaged overall, you get a first. And when we do that, here's the output for that. And we see that the margin of error is much lower, because what we're looking for is just for the diagonals from top left to bottom right to all be filled and for everything else to be 0. And when we did that across all 6 permutations, using each year as the machine learning training data and each year as the kind of extrapolated data, the LSE system is 22.1% inconsistent, whereas the normal system is only 14.4% inconsistent. So just to wrap up in 2 seconds, Matthew, next slide, please. Our recommendations aren't that we overhaul the system, because that seems quite rash to us, and there are lots of different things applying to it, but that we put more resources into it. And if you want more detail on that, please read the thing. Thank you.